Explanation.
In an article about the scientific explanation for science education, Melissa Bratton and Mark Winchell discussed 5 types of explanations. This video summarizes the main ideas from their article with examples from other research projects.
Distinguishing between description and explanation is necessary in science. Descriptions include what happens to something, and causal explanations are about why and how something happens. A causal explanation explains how and why things happen in terms of causal mechanisms.
A causal mechanism contains entities, processes, and principles. Entities are usually not directly observable, such as molecules and energy. Entities interact or change in processes. For example, in the process of electrolysis, water is split into hydrogen and oxygen. Principles such as matter conservation and energy conservation govern the processes and changes.
Here's an example. Rick took a glass of ice water out of the fridge and put it on the table. After a few minutes, water droplets have formed on the outer surface of the glass. Where did the water droplets come from?
John says, the cooler temperature of the icy water in the glass caused the water droplets to appear on the outside of the glass. John's answer describes what happened to the glass of water, not how and why it happened. John provides a description, not a causal explanation.
Lily says, the cold temperature of the icy water causes the water molecules in the air to move slower, join together, and become water droplets outside of the glass. In Lily's answer, the entities are water molecules in the air, and the process is that the water molecules move slower, join together, and become water droplets. This is a scientific mechanism. So Lily's answer is a scientific causal explanation. Sophia says, the icy water is composed of many tiny water molecules. The glass has tiny holes that we cannot see. It's like empty spaces between molecules. The water molecules came out from those tiny holes and formed water droplets outside of the glass. In Sophia's explanation, the entities are water molecules inside the glass, and the process is that the water molecules move to the outer space of the glass. This is a non-scientific causal mechanism. So Sophia provides a non-scientific causal explanation.
From these examples, we learn that descriptions are not explanations because they do not contain a causal mechanism.
Let's look at a question. Why does salt dissolve in water, but not in oil? Explanation 1 is, because like dissolves like. This explanation may sound reasonable at first. However, it is not telling you anything about why salt dissolves water but not oil. This is because there was no causal mechanism provided. The explanation tells a law or a pattern that applies to many situations, but not why that law applies. Now let's look at another explanation. Water molecules are polar. Oil molecules are nonpolar. In a water molecule, the oxygen end has negative charge, while the hydrogen end has positive charge. Salt is sodium chloride. After you put salt in water, the positive hydrogen end drags the negative chloride ions away. The negative oxygen end drags the positive sodium ions away. This is the mechanism happening at the atomic molecular scale. It explains our observation at the macroscopic scale. From these examples, we learn that covering law explanations are not causal explanations because they do not contain causal mechanisms. Let's look at another example. In a small town, some residents are developing an unlikely form of cancer. At the same time, these residents have been exposed to a particular carcinogen from a newly introduced food.
There is a correlation between 2 events, development of a cancer and exposure to a carcinogen. This correlation does imply causation. We do not know if there is a causal mechanism that explains how and why the carcinogen causes the cancer. The cancer may be caused by other factors.
From this example, we learn that an explanation derived solely from correlations is not a causal explanation because it lacks a causal mechanism. Let's look at another example. Why do water molecules move from lakes to clouds and to the ground? A student answers, water moves this way because animals and plants need water to survive. This answer is pragmatically driven. It assumes that things happen for a purpose. When designing student assessments, we should avoid asking questions leading to pragmatically driven answers. Although such answers are rational, they do not provide information about students' views on how and why things work. Let's look at two questions. Should we use fluorescent light bulbs to replace incandescent light bulbs at home? My dad is going to buy a new car. Should he buy an SUV or a sedan? Do you think these questions would be effective in diagnosing students' misconceptions? These questions are not effective because they will elicit pragmatic explanations. Students may say, "We should not use fluorescent light bulbs to replace incandescent light bulbs because fluorescent light is not comfortable." Or, "Your dad should buy an SUV because he drives on mountains." Let's look at two questions that have proved effective in eliciting students' intuitive ideas. Question 1. Is it possible that a 13W fluorescent light bulb will give off about the same amount of light as a 60W incandescent light bulb? To answer this question, students must explain the mechanism, how a light bulb can produce a large amount of light with a low wattage.
Question 2. A car burns 1 gallon of gasoline, which weighs about 6.3 pounds. Is it possible that this process will release about 19 pounds of carbon dioxide? To answer this question, students must reason about the mechanism, the combustion of gasoline.
From these examples, we've learned that pragmatic explanations are rational, but they are not causal explanations because they do not contain a causal mechanism. Let's look at two phenomena. Phenomenon 1. The average person sweats between 0.8 liters and 1.4 liters during an hour-long exercising. Cellular respiration explains this phenomenon. Glucose reacts with oxygen to produce water and carbon dioxide, and our sweat is water.
Phenomenon 2. The car burnt 2 gallons of gasoline after running 30 miles. The process of combustion explains this phenomenon. In combustion, octane reacts with oxygen to produce water and carbon dioxide. Although cellular respiration and combustion are two different chemical reactions, they are both oxidation processes in which organic carbon-containing molecules react with oxygen to produce carbon dioxide and water. Explanatory unification refers to that explanations of different phenomena are unified into generalizations through use of major theories in science.